Hi, I'm In Mojang. I am a member of RainHub and an honorary research associate at the University of Manchester. I recently moved back to South Korea and I started to work at Samsung Electronics as a robotics research scientist. Today, I'm going to present one of my research I have done in Manchester, which is virtual kinesthetic teaching for bimanual teleoperation. One of the potential applications that we have been looking at in RainHub is nuclear telemanipulation. As you can see in the left figure, normally this task needs human operators who are wearing protective suits and using a Glovebox to manipulate nuclear materials. However, due to potential risks to the human operators, we are looking at teleoperated robotic manipulators, as you can see in the right-hand figure, to replace the human workers. However, still there are research questions in terms of how to improve transparency between the master and slave and how to improve the overall system performance as well as safety. Particularly, we are interested in using virtual reality, so now let's scatter existing user interfaces for virtual reality telemanipulation in this graph. The graph has y-axis, which represents system complexity and cost, and the x-axis represents intuitiveness and immersiveness when a user uses these interfaces. The simplest interface is to use VR handheld controllers. In this case, a user can have intuitiveness in controlling the robot's end effector in Cartesian space. However, when the operator wants to control the robot gripper, only the trigger button can be used, which only can provide a on-off binary information for gripper. Another interface might be to use a data glove, as the data glove can collect the user's hand gesture information, which can be transformed to corresponding grasping commands to the robot's gripper. We can achieve additional intuitiveness in grasping on top of controlling the arm. If we have an exoskeleton glove, then we can also have haptic feedback, but the system will be very complex and expensive. Here, I would like to also mention that the interfaces are becoming more heavy and bulky, from the VR controller to haptic exoskeleton glove, which may also cause fatigue in the operator's hand or arms during long-term operation. In this work, our aim is to propose a glove-free and marker-free interface, but which also provides intuitiveness in both arm and gripper control. Kinesthetic teaching is a method whereby a human physically manipulates the part of a robot or its end effector to construct a series of configurations for a required task. This method does not require robotics programming knowledge, and it is easy and useful in industrial settings, so many commercial robot manipulators already adopted a sort of kinesthetic teaching interface. Recently, Bristol Robotics Lab utilized kinesthetic teaching for telemanipulation. This method uses two identical robots for the master and the slave side. As the operator pushes and pulls the master robot, the slave robot also follows the movement. Here, another feature is that in order to open or close the gripper, the operator has to use this gripper button. For more details, you can probably talk to Alex or Paul in the workshop. In this work, we propose virtual kinesthetic teaching for telemanipulation. Here, instead of having the identical master robot in the real world, we have a digital twin in the virtual reality. The operator does not need to have any wearable glove, but uses a lip motion sensor on top of the VR headset. This sensor captures the operator's hand in real time. In order to interface with the digital twin, we have an interactive marker which is pre-imposed at the end effector. Here, we designed the VR marker such that only one hand is enough to control the robot arm as well as the gripper simultaneously. Now I will show you our demonstration video. The first demo shows our pick and place test. The proposed interface is intuitive and easy to use. We were easily able to succeed the task. However, the robot has some jerky motion because in this demo we used Amazon Web Services to connect the master and the slave side. In the second demo, there are randomly scattered paper pieces and we try to sweep them into the center of the table. We particularly chose this sweeping demo because it is known as a common task in the nuclear Glovebox operations. And in this demo, we used local network, so the slave robot's movement was so smooth. And this is an overview of the system architecture. Thank you for listening my talk. I'm sorry that I was not able to provide much details due to the time limitation, but you can always email to me or talk to my colleagues, Halin or Joaquin in the workshop. Thank you, and I hope to see you again.